Hello, my name is Oscar Venegas, and I'm going to present my final project, which name is Non-Cooperative 5G UE Localization via Deep Learning-Based Angle of Arrival and Doppler Estimation. So what is the problem statement here? So the problem basically is try to localize a non-cooperative 5G handset or user equipment within a non-friendly or non-cooperative 5G network, which means that we have an external 5G network and we want to localize where a UE is transmitting. The technical challenges of this is basically that we have to deal with multipath, and the main problem is we don't have the cooperation of the 5G network, which means that we have to use the signal opportunity that the 5G network provides us. The related work. So this is not a new problem at all. This problem has been studied for years, for decades, I would say. From traditional methods such as angle of arrival using Capone estimation, music estimation, for time difference of arrival, time of arrival using, for instance, a geometry of 3 receivers, and based on this we can identify and track IUE. What is the difference with this? That what I want to do, or what I implemented, is try to localize a UE in a non-friendly 5G network, because most of the traditional methods they use time difference of arrival from the operator perspective. That is, they have access to all or most of the information available in the 5G network, which was not our case. The list of materials basically is a user PX410, which is the 5G transmitter or the 5G G-Node-V, a Google Pixel 6a, which is the handset that we are going to try to localize. I implemented my algorithm in an NVIDIA Jetson Orin Nano using Ubuntu 22.04. The receiver radio is the USRP V210. And the antennas are omnidirectional antennas, LCOM, covering wide frequency range. This is the setup. On the left side, you can see the white antenna. That white antenna is the G-Node-V transmitter. In the middle, we have basically on the left side the X410, which is the G-Node-V. On the right side, you can see the Jetson Nano connected with the V210 and the array of 2 antennas that I implemented. On top, on purple, you can see how the UE is attached to the current 5G network. And then the machine learning model that I used was as a final objective, basically to improve and help these traditional localization methods in order to get a softer output. The data collection and validation. So basically the data that I used was IQ samples using 16 bits for real, 16 bits for imaginary, using 10 megasamples per second, and they were organized in 0.5 in windows of 0.5 seconds. Okay, for the validation or the ground truth, I use video and manual measurements. The machine learning model, I chose to use a CNN model in order to get a better result of the traditional angle of arrival and Doppler localization. So here you can see a little more of my hyperparameters as well as the number of layers that I used. These are the results. On the left side, it is the video, and in the small window, you can see how the angle estimation is done. This particular screenshot was taken or was took from the video that I'm going to upload. On the right side, you can see a Doppler map where you can distinguish basically the range and the Doppler shift.